Hey guys, how's it going? Here we are once again with chapter 4b. Today we're going to be continuing on from the last section that we just did, which was section 4.7, which dealt with transformations. Today what we're actually going to go ahead and do is talk a little bit more about two of the types of transformations that we learned. We're going to talk about translations and reflections. Alright, so in today's lesson we'll be able to identify translations and reflections, and we're actually going to be able to draw them on the coordinate plane. So let's go ahead and get started right away on this. First, remember that's one of our three different types of transformations. So a translation is a transformation that moves all points of a figure the same distance in the same direction. A translation maps each point to its image along a vector called a translation. Oops, totally misspelled that. Let me redo that again. Translation vector. So what does that mean? All this means really is, let's say for example you have some sort of figure like, I don't know, a square, okay? Then each point of that square is going to move according to our translation. So for example, if the top left corner moves down 2 and to the right 5, then every single point on that box, on that little square, is going to move down 2 and to the right 5, okay? So every single one will move the same distance and in the same direction. Okay, and this translation vector is what's going to help us identify which way we're really going. Okay, so let's go ahead and talk a little bit more about what that looks like. So it says the transformation statement of a pre-image to the transformed image is written triangle ABC to triangle A prime B prime C prime. Okay, that's what those little tick marks mean. All right, so let's go ahead and see what this looks like on the coordinate plane. So notice my symbol here in my translations, I'm going from x comma y, so those are my regular x comma y points on my figure, but then I'm adding a certain number to either my x or a certain number to my y, and that might be adding or subtracting. All that really means is how much am I going to move left and right when I add or subtract to x, and how much am I moving up or down when I add or subtract to y. So it says, translate a point along a vector a comma b, add a to the x coordinate and b to the y coordinate. So let's just make sure I understand exactly what that means. I'm going to take this point right here. Notice look at my example right here, guys. To get from that point to that point, okay? All right. So notice my translation vector. All right. Well, but I need to know in what direction I went. I went down 2 and to the right 1, 2, 3, 4, 5. So down 2 and to the right 5. Well, okay, up and down is on my y, right? So technically right here I would have y minus 2. And then on my x I would have x plus 5. Alright? And maybe that doesn't make too much sense just yet, guys, but it will in a second. So just keep that in mind. I'm going to go ahead and erase all of this for now. But just keep that in mind as we do some of these example problems, okay? So it says write the translation rule. So we're going to have to write a rule kind of like what we had up here, guys. Kind of like what we have right there, but with the right numbers to show in what direction we're moving. All right. So let's take a look at this. So we're looking at triangle LMN to triangle L prime M prime N prime. Okay. So each of these, remember what we said, translation moves every single one of our points in the same direction and the same distance. So why don't we actually take a look at point L? From L to L prime, we went in what two directions? Let's see. I went 1, 2, 3, 4, 5 down, and then I went to the right 1, 2, 3. Well, okay, let's make sure we understand what those mean, guys. So we definitely are going to start from x. Oops, let me do that. X comma y. And we are translating to x and y. Now, this is where we determine in what two directions I moved. Well, I moved I moved down 5, and up and down is my y. So I moved down 5, and I moved to the right 3. That's on my x-axis, so plus 3. Okay, so my translation rule is from x comma y, I went to x plus 3 and y minus 5, meaning every single point is going to do that exact same thing. If you don't believe me, let's do this. Let's go look at n. From n to n prime, I should be able to go down 5 and right 3. So 1, 2, 3, 4, 5, and to the right 3. And look at that. Yes, I am at my other point. The same thing would work with my m's. From this m to this m, I can go down 1, 2, 3, 4, 5, and to the right 3, and I am also at my m prime. Okay, so that is my rule for that one. So what I want to do is I'm going to actually have you guys try out the next one. So go ahead and try out example number 2. Alright, so go ahead and pause the video right now and give that a shot. Alright, let's go ahead and take a look to see if you guys did it correct. So we are translating this figure A, B, C, D, E to A prime, B prime, C prime, D prime, and E prime. That was a mouthful. Alright, so that's what we're doing here. So what I can do, again, from any one of these points, I could just go to its corresponding point on the other figure. So once again, let's figure out from A to A prime, in what two directions did I go? I went down 1, 2, 3, 4, just 4, and then I went to the right, 1, 2, 3, 4, 5, 6. So right 6 and down 4. So let's write our rule. X comma y transform to. Now it's just like to put my x and y. I need to know in what two directions. Remember, x is left and right, y is up and down. So left and right, I went plus 6 on my x, and I went down 4 on my y. Alright, so my rule is x plus 6 and y minus 4. Alright, so hopefully you guys had that as your answer for number 2. Let's go ahead and move on to example number 3. So it says, given triangle EFG with vertices -7, -1 for E, F is -4, -4, and G is -3, -1, transform the pre-image, so that EFG is our pre-image, to the rule x plus 2, y plus 5 to create my new image, which is E prime, F prime, G prime. So let's actually go ahead and graph the original. Let's graph EFG. So E was -7, -1, E, and then -4, -4 is F, and then -3, -1. Right around there. So that is my triangle EFG. Let's go ahead and graph it. Now, what we have to do is take each of these and go ahead and add 2 to my x. So I'm going to move to the right 2, and I'm going to go up 5 from each of these points. So let's do that. So I'm going to go from E, I'm going to go right 2, 1, 2, and up 5, 1, 2, 3, 5. I'm right there. That is my E prime. I'm going to do the same thing for G. So I'm going to go to the right 2, 1, 2, and up 5, 2, 5, right there. And then on my F, exact same thing. I'm going to go to the right 2 and up 5, 1, 2, 3, 4, 5, right there. Actually, this is my G prime. All right, and I can go ahead and draw my Alright, look at that. So again, notice my triangle looks exactly the same. The only thing now is that it translated, it moved. It kind of went on a little bit of a slide, alright? It went up to up 5 and to the right 2, so every single point did that. Alright? So once again, guys, I'm gonna have you guys try the next one. The only thing I'm gonna give you as a hint is look at your numbers here. The rule is that you have to go left 3 and down 4. Okay? When you're looking at left and right, a positive means right, a negative means left. When you're looking at up and down, a positive means up, a negative means down. So go ahead and draw your figure JKLM and then go ahead and draw your new image. So go ahead and give that a shot and try that out. Alright guys, so hopefully you had a shot to try that on your own. I'm going to go ahead and graph this pretty quick. So J is at 3, 4. K is at 5, 2. L is at 7, 4. And M is at 5, 6. So M, L, K, and J. Okay, that's my original figure. So I'm going to go ahead and just connect all my dots. So that's my original square. Alright, now I'm going to go according to my rule. My rule tells me to go left 3 on every point and down 4. So I'm going to go ahead and just start with J again. So I'm going to go left 3, 1, 2, 3, and down 4, 1, 2, 3, 4. Looks like I'm right there. That is my J prime. Now I'm going to go ahead and do K. So left 3, 1, 2, 3, down 4, 1, 2, 3, 4. Same thing with L, left 3, down 4, and same thing with M. So this is my new image, and this is J prime, K prime, L prime, and M prime. That is exactly what your figure should look like. Alright, so we had a pre-image, which was my black figure. Alright, we went according to our rule, which told us to go left 3 and down 4, and we end up with our new image, which was J prime, K prime, L prime, and M prime. Alright, so I think that is enough for translations. Alright, the next one we're going to be talking about is the second part of our topic for today, which was reflection. So, a or a flip is a transformation over a line called a line of reflection. Each point of the pre-image and its image are the same distance from the line of reflections. So let me just show this. The pre-image is the original, and its image is for its reflection. Okay, so let's reread that again. A reflection or a flip is a transformation over a line called a line of reflection. We learned that in the last section. And then it says each point of the original and its new image are the same distance from the line of reflection. Okay, so we're going to take a look at exactly what that means here. So the first one, if our line of reflection is the x-axis, okay, meaning like right here, and this gives us a little bit of a diagram, but if that red line, that x-axis is our reflection, our line of reflection, then to reflect a point over the x-axis, you have to multiply its y-coordinate by -1. Okay, so what does that mean? Well, let's say, oh, I don't know. Let's say, for example, that for this point P, let's say my y was 2. Okay, notice how I changed that on my example. If it was 2 for my original point P, for my y, then 2 times -1 would be -2. Alright, so that's going to bring my image, my new image, down actually. So notice how it's going from P to P prime. It started up top, but now it's reflecting over the X, so now it's actually going to come down. Okay, so if it reflects over the x-axis, notice my x's stay exactly the same. Only one that changes is now my y. My y is now going to be negative y. So whatever your y was, you have to change it to a negative y. It's almost the exact opposite with my y-axis. So if my line of reflection is my y-axis, notice that my y's are the ones that are going to stay exactly the same now. What's changing is going to be my x's. If it started off with x, now it's going to be a negative x. So let's read our description. It says, to reflect a point over the y-axis, you have to multiply its x-coordinate by -1. Well, that's exactly what we did. So once again, let's pretend for a second here that my original p was, I don't know, looks like we are at negative, something like -5. Well, if I multiply it by -1, I'm going to get a positive 5 for my p prime, which makes sense. On the left side, I'm at -5. On the right-hand side, I'm at positive 5. It makes sense because I'm reflecting over this line, the line, or the y-axis more specifically. Earlier, we reflected along the x-axis. All right? So those are the differences between those two guys. So if you're reflecting along the x-axis, keep the x's exactly the same and just change your y's. If you're reflecting over the y-axis, keep the y's the same and just change your x's. If it was a positive, make it a negative. If it was a negative, make it a positive. All right, and then finally we have one more. We have a reflection when the line y equals x. So let's talk about that. So it says to reflect a point over the line y equals x, you have to interchange the x and the y coordinates. So let's see what we have. So my x and my y. Notice when I reflect over the line y equals x, my x now turned into my y, and my y now turned into my x. Look at that. It's almost like they flipped. So let's say, for example, I had the original coordinates 3, 4. My new coordinates are going to be 4, 3. All right, that's exactly what that rule means. And actually, maybe I should give you guys examples of the top ones. If my original here was 7, then my new one is going to be 3, -7. Okay, let me give you an example of this one. If my original was -5, 2, my new one is going to be 5, 2. All right, so those are just quick little examples of what all of these different reflections look like. Okay, they're a little different from translations because we have more specific rules that we have to follow. All right, so why don't we actually go ahead and start looking at some of these examples. So it says graph each figure, the pre-image, and its reflection, the new image, over the given line. I'm going to actually go ahead and try example number 5, and I'm going to give you guys a shot to do example number 6. So it says number 5, triangle XYZ with vertices x equals 0, I'm sorry, 0, positive 4. Let me go ahead and graph that. 0, positive 4 is right here. -3, positive 4 is my y. And -4, -1 right there. Whoops, did I do that right? -4. Yep, that looks good. -4, -1. So I'm going to go ahead and graph this thing. And sorry if my lines look a little bit off, but this is your x, y, and z. Okay? So now, we want to reflect this thing over the y-axis to get x prime, y prime, z prime. All right, so we said the y-axis reflection over the y-axis. So what's our rule? Reflection over the y-axis is this one. Okay, x comma y is going to turn into negative x comma y. Let's do it. X comma y is going to turn into negative x comma. So let's take all of our points. Let's see what we get now. So my original x, y, and z were what? They were 0, 4, negative 3, 4, and negative 4, 1. And now they're going to be reflected to our new image, which I'm going to go ahead and put blue here, and my new x prime, y prime, z prime. And what would those coordinates be? According to my rule, remember, my y's are going to stay exactly the same. I can go straight to writing all my y's. It's going to be 4, 4, and negative 1. But now, my x is now going to turn into a negative x. So all my x values are going to turn into the opposite of that. So the opposite of a 0 is just a 0. So that one kind of stays the same. Opposite of a negative 3 is now positive 3. And the opposite of a negative 4 is a positive 4. I now have my new image here, guys. Look at that. I have my new image. Let's graph it. So 0, 4, and then 3, 4, and 4, negative 1. And there it is. Now, let me retry that last line. Definitely hard to draw on these computers. Alright, there we go. So this is going to be my x prime, my y prime, and my z prime. And once again, notice, guys, notice that does look like a reflection. A reflection over what? A reflection over this line right here. And what line is that? That is my y-axis. So if you pretend that y-axis is like a mirror, then the image that came out looks pretty reasonable, right? So that is correct. That is what you should have for your new image. So what I want you guys to do is please go ahead and try out example number 6. Go ahead and do it exactly the same. The only thing I want you guys to focus on is this. It says it wants it to reflect over the x-axis. So look up here. Look up at your rules. The x-axis rules or symbols tell you to do what? That every x comma y is now going to turn into an x comma negative y. So let's do it. So every x comma y is going to turn into an x comma negative y. So go ahead and graph your image. Go ahead and graph, or I'm sorry, your pre-image, and then go from there. Okay. Go ahead and set up your Q, R, S, T, and then figure out what those order pairs are going to turn into. Okay. So go ahead and pause the video at this time and give that a shot. Alright, guys. So hopefully you guys had a chance to graph this thing. So let's go ahead and graph our figure QRST. So we're at -1, 4 Q, 4, 4 for R. Whoops, that's a little high. 4, 4 for R. S is 3, 1. And T is -2, 1. So right there. There we go. So we have our original. Let me make sure we have the correct coordinates once again. We have -1, 4, 4, 4, 3, 1, and -2, 1. Now, It says we want to reflect over the x-axis. So we're going to reflect along this axis right here. Okay, maybe you can already kind of picture in your head what this is going to look like. Okay, so like right here, this is exactly 1 unit up, so it's probably going to be 1 unit down. This is 4 units up, so it's probably going to be 4 units down. But let's not speculate. Let's actually graph this. So my new Q prime, R prime, S prime, and T prime have to follow this rule. X's have to stay exactly the same, but my Y's are going to turn opposite. They're going to turn into a negative version of it, or if it's already negative, it's going to now turn into a positive. So let's finish this off. So let's find our new coordinates. Well, what did we say? Look at my y, or my x's, sorry. My x's should stay exactly the same, so I'm going to go ahead and rewrite them. -1, 4, 3, and -2. But my y's are now going to turn into the exact opposite. So this is going to be 4. Instead of a 4, it's going to be a -4. Once again, instead of a 4, it's going to be a -4. Instead of a 1, it's a -1. And instead of another 1, it's going to be -1. Okay, so let's go ahead and graph those. -1, comma -4 is right here. That is my Q prime. 4, comma -4 is my R. Right there. 3, comma -1 is my S. And -2, comma -1 is my T prime. Alright, now I just connect those. And once again, notice that looks pretty good. Alright, they are reflecting over that line. In this case, this line is called the x-axis. We're reflecting over the x-axis. So if you got that as your answer, then you guys are on the right track. Alright, now we're going to go ahead and solve this final one. This is going to be a little bit more tricky because we are using the other rule. So it's not going to be as apparent as whether or not we did reflect along the right line, but I think it'll make sense once we have it all complete and done. Alright, so let's see what it says. It says triangle ABC with vertices A, B, and C are want to be reflected over the line y equals x. So before we even get started, let's check our rule. Well, we want this rule, that x comma y is now going to turn into y comma x. So they flip, right? So x comma y has to turn into y comma x. Right? So why don't we actually go ahead and graph this thing first off. A is at -5, 8. B is -1, 5. And C is -4, 0. So right there. Okay. All right. Now let's go ahead and write down all of my original coordinates. All right. And my original coordinates are what? They are -5, 8. They are -1, 5. And -4, 0. All right. But we are reflecting here. Now all of my coordinates, so A prime, B prime, and C prime are going to switch roles here. All my x's are going to turn into y's, and all my y's are going to turn into x's. Alright, so what does that mean? That means I basically have to flip-flop these. Alright, so this is really going to be 8 comma -5, 5 comma -1, and 0 comma 4. Notice they all flip-flop, guys. That's happening here. Okay, my x's are on the outside, and my y's are on the inside. Okay, so let's go ahead and graph this new triangle, A prime, B prime, C prime. So 8 comma -5 is right here. This is A prime. and then b prime is 5 comma negative 1, and finally c is 0 comma 4. Right? Let me go ahead and graph this thing. Alright, there it is. Now, as I said, guys, this one might not look too apparent. And the reason why is because you don't see the line of reflection yet. But hopefully this will help. The line of reflection was the line y equals x. That is this line. So, hopefully this will help visualize it a little better. If you go like this distance looks to be about this distance. This distance here looks to be about this distance there. And finally, this distance here looks to be about that distance there. So now, hopefully, that'll start to look a little bit more like the reflection that we wanted. And actually, this is correct, guys. These coordinates and these new pre-images and images are all correct. Alright, so again, that last bit that I did there, you don't have to do that. That was just to give you more of a visual of exactly what is happening. But this, I do want you guys to include at all times. Always tell me where my axis of reflection is, or my line of reflection, rather. Okay, so here was y equals x. Above here on problem number 6, it was the x-axis that was my line of reflection, and then finally my y-axis was my line of reflection for number 5. Okay, alright guys, so I think this is it for today, so I'm going to go ahead and stop the video here. If you guys still have any questions, make sure you guys reach out and get all of your questions answered. Please make sure you feel comfortable with the material before moving on, guys. Make sure you feel comfortable so you don't come to a test or a quiz and feel not too solid on the content just yet. So make sure everything makes sense. Ask any questions that you may need, and we'll go from there. Alright guys, we'll have a good one, and I will talk to you guys soon. Bye.